All right, welcome AP Calculus. Let's do this. Lesson number 37, related rates with one formula. So here, the idea of this setup is if we have some sort of problem with related rates, and what does it mean to have a related rates type of problem, I'll explain that. But usually, this is a nice setup that I think we should get into the habit of doing. So here, it's asking us, what do you know, what's given, what are you asked to find, can you create a visual, and what does your solution mean in the context of the problem? Okay, so let's just actually read the problem together. Here it says the area of a circle is decreasing at a constant rate of 211 square meters per minute. At the instant when the area of the circle is 81 pi square meters, what is the rate of change of the radius? Round your answer to 3 decimal places. So let's just break this down. What information do you know? Okay, let's take a look and let's read this step by step. So here it says the area of a circle, right? So do we know the formula for the area of a circle? Let me zoom in a little bit. Okay, so what do you know? For sure, we know that the area of a circle, A is equal to pi r squared. Okay. Now let's take a look at the next piece of information. It's saying that the area of the circle is decreasing at a constant rate of 211 square meters per minute. Now, how can we actually take what this is saying and translate it into a mathematical explanation of, like, a mathematical formula, right? So let's just read it again. It says the area of a circle, so we know that's A, is decreasing at a constant rate. So just because it's saying this part over here, I'm sorry for all the colors, is decreasing at a constant rate, you know this has to be some dA dt, because it's saying over time the area is changing. Now, how is this area changing? It's decreasing, so we know it's negative, at a constant rate of 211 square meters per minute. Now, how do you translate square meters per minute? Let me underline this over here. Square meters per minute. How would you translate that? That would be meters squared per minute. And that's it over here. It's saying how would you translate this? It's decreasing 211 square meters per minute. Okay? Now, let's take a look at the next piece of information. Here we have at the instant when the area of the circle is 81 pi square meters. So how do you translate this right now? How would you translate this? Here it's saying the instant when the area. So here we have area again, but now it's saying that it's constant. It's saying that it's not changing. So the fact that this is not changing, we're just going to leave it as A. And we're going to say A is equal to 81 pi meters. Meters squared. Right? Okay, because before it was saying it's decreasing at a constant rate, so we had that dA dt. But here it just stays as it is. Now it's asking us, what is the rate of change of the radius? How can we take this information and translate it into something mathematical for us? This would be, what I want you to do is see what the question is asking you to find. Let's see how clever you are. What is this question asking you to find, and how do you translate it? Well, it's asking you for the radius, right? But it's asking you for the rate of change of the radius. So you have dr dt equals question mark. Okay? We want to find what this is. Now, it's saying round your answer to 3 decimal places. Okay, we'll get to that. But we have to have a visual of what's happening. So let's reread this again. It's saying that the area of a circle is decreasing. So if you have some sort of circle, and remember the area is what's on the inside, right? It's saying it's decreasing. So you know your area is of your circle is getting smaller and smaller. So maybe At 0 seconds, it's like this. At 1 second, what's happening to the area? It's decreasing by 211 meters squared per minute. So what that looks like, we don't know, but we do know that the circle keeps getting smaller and smaller and smaller and smaller, right? Now it's saying, what's the question asking? It's saying, what is the rate of change of the radius? So you know that this circle has a radius of something, okay? Now notice what's happening to the radius every single second. The radius of the circle is getting smaller. And that's what the question is saying. It's saying, at what rate is the radius getting smaller? And how would we actually find that out? Okay. So how do we actually mathematically solve this using calculus? So we know, let's use what we know. We know that a is equal to pi r squared. Now notice, what do you think you're going to have to do based on the information you have? What do you feel like would be the next move to do? And pause the video and really think about it before you actually hit continue. What you're going to have to do is, you're going to have to take d dt on both sides. And what was the clue that made me think take d dt on both sides? Because you're given information about change of time, and you're looking for the change of radius with respect to time. So that idea is, let's differentiate both sides with respect to t. Now, how do we actually take the derivative of just a? Notice, what's the derivative of a? It's just dA dt. Now, the question is, how do you take the derivative of pi r squared? So let me get this paper over here. If I want to take the derivative of pi r squared, okay? And notice you're going to take d dt on both sides. Notice that r is a variable and pi is a constant, okay? So imagine if, let's forget about pi for a second. Imagine if I just said, hey, what's the derivative of 2r to the fourth, right? With respect to t, and you're going to take d dt. What would this be? Notice you just do 8r cubed dr dt. Okay, you're treating that 2 as a constant, right? You're going to treat this pi, it's a constant. So all this becomes is this pi r squared. It just becomes 2 pi r dr dt. Okay, and that's what we have so far. Now, what do we know? Do we know what dA dt is? Yes, we know what dA dt is. It's right here. Do we know what pi is? Yes, we also know that pi is equal to 3.14. Do we know what r is? No, we don't know what r is. So, what is r? But do we know what dr dt is? No, because that's what we want to find. So, how do we actually continue forward? We need r. What is r and what does it represent? The r represents the radius of the circle. So it's saying in the problem, it's saying when the area of the circle is 81 pi meters squared, hey, if we know what the area is, can we figure out what r is? Question mark. And let's see how clever you are. If you know a is equal to pi r squared, and you know a is equal to what? A is equal to this 81 pi meters squared. Can we figure out what r is if we know what a is? What I want you to do is try and do that right now. Okay, what would you do? Notice a is equal to what? 81 pi meters squared equals pi r squared. Now, how do we get r by itself? What are we going to do? Let's first divide both sides by pi. And notice that these two pi's cancel out. This cancels, this cancels. So notice you have 81m squared is equal to r squared. Now, how do you continue forward with this? How do you get r by itself? Pause the video and try and see what the next move is. Don't wait. Take your time. Square root square root. So what's the square root of r? The square root of r squared is r, and 81m squared is just 9m. So notice that we were very clever. We were able to figure out what r is. And now, great, now we could plug everything in. Because here, what is dA dt? It's just negative 211, okay? What is 2 times 3.14? And what is our radius now? It's 9. And don't worry about the units of measurement. Don't worry about like the meters squared per minute and the meters. We'll do that at the end. So notice now we have dr dt. Now, can you get dr dt by itself over here with what you have? Yes, you should be able to. And what I want you to do is everybody try and solve this formula right now. How do you get dr dt by itself? Okay. And as you do that, I need to get the calculator because you definitely need a calculator to actually do this. Okay. So let's see. Here, let me turn my calculator on. It's been a minute since this has been on. Okay. First, let's calculate this. So it is 2 times, I guess we could be very specific and put it in pi. So 2, where is pi? Second pi, times 9. Okay, so notice that this is 56.548666776. So what we're going to do is we're going to divide this negative 211 by 56.548666776. And then you see, because this is what this is here. So notice we're going to do that on both sides. This cancels. So dr dt is equal to, okay, so now we got to do negative 211 divided by 56.548666776, and that equals to negative 3.731299222. Okay, now let's just pause for a second. What does this solution mean in the context of the problem? What does this dr dt represent? Take a second and try and pause the video. Try and explain to yourself, what does this mean? Okay. Notice it's saying, what was the radius initially? Your radius was 9. Every second, the radius is decreasing by negative 3.7312, or actually let's round it. I'm sorry, I forgot. Here, don't you remember it says round to 3 decimals places? So this becomes negative 3.731 meters per second. It's saying every second, the radius of the circle, right? If this is the circle and this is the radius of the circle is decreasing by this much. And that's what it means for let me write that down. Every second, the radius of the circle is decreasing by 3.731 meters per second. Okay? Good job. I know that was a lot, and we had to do everything step by step for the first one. And these do get better. What I want you to do is, for question number 2, same idea, same sort of question. Here, you have some information. What I want you to do is try and do this problem on your own. And in the next video, I don't have time because I got to go teach my next class, but in the next video, I'll go over the solution for this, okay? And if you feel like, oh, Mr. G, I have a question, what I want you to do is just email me and I will answer your questions. Okie dokie? Try and do this question by yourself. And in the next part of lesson number 37, notice that question 1 and question 2 are talking about circles. What about question 3 and question 4? Question 3 and 4 are talking about a sphere. Question 5, question 6, it's talking about a cone. Question 7, question 8 is talking about a cylinder. And we have to be okay with all these 3D geometric shapes. Okay? Enjoy.